Probability is favorable. Oops, if I can spell. Forward. Probability is a fraction. It's a ratio. It is what we call favorable outcomes divided by total possible outcomes. Bless you. So when we talk about it, obviously a very easy thing to think of is just flipping a coin. If you want to flip a coin, how many possible outcomes are there? Two. You have heads or tails. So if you want to, the probability of flipping and getting tails would be 1 out of 2, 50%. Okay. What we're looking at here, bless you. The way that we write this is this. Oops, bad parentheses. I would say, what is the probability of flipping and getting tails? With 1 out of 2. There's the favorable outcome, total outcomes. 2. Okay. Same idea. So probabilities will always, always, always be a fraction. Probabilities are always between probability of some outcome is always going to be greater than 0, less than 1. Probability will never be greater than 1. Probability will never be less than 0. If probability of something equals 0, what do you think that means? It's not going to happen. And it's a definite not going to happen. Like the probability of you not having homework. Not going to happen. Okay. Therefore, the probability if a probability of something equals 1, it's a certainty. Certainly gonna happen. And that's kind of the basics of probability. As you get into probability more and more and more, you can really, start talking about hands on decks of cards. You can start talking about draws of lottery. You can start talking about all these different applications or parts of probability. Gambling is all probability and chance. Okay, higher risk, higher reward, depending upon what you're looking at. For example, if you guys know the Powerball stuff, right? Yeah, yes, sir. I usually do that now too. I talk about. I usually. I'm not gonna lie. It is a great. It's not that I teach you how to gamble. I teach you how the expectancies of things that you have. Ish. Yeah. Yeah. It's one of those things that if you start to think about the idea of card counting, like you're saying, a single deck of cards you could probably keep up with not too much of a hassle, to be honest with you. One of the reasons why I don't play cards is because my mind will start seeing cards and I will start trying to, my brain just starts counting and I just want to try to figure out, okay, what's the next thing? And it bothers me. So I really dislike playing cards because my wife's like, well, why do we always play cards? Because I hate it because I'll do that, but if they start playing some other stuff, like it just starts getting into my head like that. Now, the other thing, if you start thinking about, hold on, guys, hold on, awesome, just stop, okay? The other thing is that if you get into Vegas, they have what's called a shoe, I think is what they call it. And in that, there's 8, 9, 10 decks of cards. So you start thinking about it, you've got, instead of 52 cards, you've got 800 of them, you know, or it just becomes so much more and more difficult. That's why they do that.
416.
You got things go through. What's that?
416.
Anyway, so you get something like that. Thanks, sir. That's one of the things I don't really mess a whole lot about anymore. Now, when we're talking about geometric probability,
I see the every stuff.
we talk about geometric probability. Let's see if I can do this a little cleaner.
And Mr. Murphy,
Yes, sir.
have you tried to meditate?
If I tried to meditate, sure.
Yeah.
Now, if I want to get into this a little bit more, we start talking about probability of shaded regions. So it's still shaded region problem, but you're looking at what is the probability of landing or picking a point that lies within a shaded region. Okay? So if you want a probability of the shaded region, what we're going to look at is in terms of areas. Okay? So you're going to find basically what we've been doing. You're going to find areas a couple of times and then just divide them out to get some ratio, some fractional. Okay. So if I want to find the probability of landing within a shaded region, I have to first of all figure out how do I get the shaded region area and what's the overall region. Well,
for a rectangle, it's based on size.
Yeah, if I'm going to do probability of shaded region, it's going to be the area of the large
Which is based on size.
rectangle, subtract the area of the small rectangle, and then what was the area of the biggest object here? The big triangle, or the big rectangle.
Yeah, triangle.
Yeah, that too. Two of them. That's kind of what we wind up doing here. You're going to find the shaded region like you would normally. You know, base times height, subtract the base times height to get the area of the blue. And then what you would do is divide that by the area of the large object. So let's just make up some numbers that seem to make this relatively simple. If we say this is 20 by 8, and then this one would be, I don't know, 16 by 6. Okay? So if I want to find the area of the shaded region, that's easy. You've done that for a few days in a row now, so it's not that big of a task to worry about. We would take the area of the large rectangle, subtract the area of the small. Let me move this up just a bit here. So I'd have 20 by 8, subtract 16 by 6, and that gives me my shaded region. Let's see.
6.
You can get 64 for the shaded region. Okay. And I have to divide that then by, well, what's the area of the large object? That's the 20 by 8. There's my probability, 0.4, 4/10, or 0.4, or what is that, 2 out of 5, yeah.
Which one get written as a fraction then?
Either one. Probabilities can be decimals, fractions, and they're always going to be greater than 0, less than 1. Yes, sir?
One lowest term?
What's that?
Lowest term?
Yeah, yeah. Your calculator will do it for you. So if you typed it in as a fraction, and you did, what was it, 64 over 160, it'll give you 2/5 as a fraction. Or if you press the buttons of the calculator differently, and you got a decimal, it would just say 0.4. Either one's fine. Probabilities, either way is perfectly fine, because it's just a representation of a fraction. Okay? And that's what we're looking at. All right? 2/5, 0.4, either one is perfect. Okay? Not too terrible? Hope not.
Yeah.
Is that circle?
Yeah, it didn't show up as cleanly as I thought. So let's turn the light off so you can see a little bit better.
Still question myself.
All right. So there's a circle inside a. Get two of those again. So we have a circle inside of a square. We have a circle inside of a square, which means we have to find the area. The favorable region that I want to get is landing in, bless you, landing inside the circle. It should, yeah, it's just tough to do with the smartboard, that's all. So I want the probability of landing in the circle. So what's the favorable region?
Where? Wait.
The circle. If I want to have the probability of landing in the circle, the favorable region has to be the circle. Well, how do you find the area of a circle?
The radius.
Pi r squared. So my favorable region is the circle, pi r squared. And what's the overall shape? A square. So I have sides of 12, which means what's my radius? 6. Okay. So I get 6 squared pi over 12 squared. And again, you guys have a button on the calculator that has a fraction bar. Type that directly to the fraction bar, and you'll get a decimal equivalent. So I'd say 0.79. So you have a 79% chance of landing in the circle. That's what that means. Okay. Area of shaded regions. Yes, sir.
It also says pi over 4.
What's that?
It says pi over 4.
Oh, your answer said pi over 4?
Yeah.
Hit the double arrow then, and then just get your decimal equivalent. If it says pi over 4, that's fine. Because that's exactly that's what it is. 36 is 1/6 or 1/4 of 144. Yes, ma'am. Nope. Either one is perfectly fine. Either one is perfectly fine. With probabilities, it's fine. So how about this? Would you guys rather, anytime we do geometric probabilities, I will just say round to the nearest hundredth? Let's just do that then. That way we don't have to worry about, is it fraction okay or not? Whenever we see geometric probability, let's just say always round to the hundredth. So you'll just have to hit that double arrow button in case, just in case a bunch of times. Yes, sir? What? Yeah, but I'm just going to put in the instructions, always round to the 100. All right, that way we alleviate having to worry about it, okay? Which means this stuff gets to be even more fun.
Anybody shoot bow and arrow?
It's target.
All right, you guys have done this before, right? Why do you get more points when you have to hit like the edge or the inner part of the circle?
You don't get
Dude, yes. What he said.
Yeah, usually it
The
usually
closer
is
to the
the
center.
closer to the center.
Those values, though, are just the dimensions. That's how wide everything is.
Oh, okay.
Okay? That's the width.
Gangster. OG. You're dark. I'm just the OG.
Who else shoots bow?
Oh no.
Or you shoot bow. But did you ever go to the shooting range?
Why not? It's not a weapon, it's a toy. Yeah, it's sure. All right.
Oh, look at how cute he is.
Hey, Sam. Duck.
Where?
Come on, you gotta get the center. I think you missed it here.
Dope.
He just ran away.
It's a little bit better.
Oh, the sound didn't go off. Of course there's sound. Why would there not be sound? Come on. Oh, it's muted, that's why.
Good job.
Oh, boy.
Try one more time.
The other, it's the, yeah.
You guys take
Just
that
watch
off.
it hit the back here.
You gotta do it again.
That's why it's muted, because I still have music on.
Is that supposed to be the same?
And you have tabs inside your camera.
I got stuff everywhere. Computers don't like me. I got too many things going
Yeah,
on.
better see it.
I'm probably that whole album.
No, it's right about here. It's supposed to butter. Watch your
And
head.
did you have that in your desk?
Oh,
No.
yeah. I got it. I got stuff everywhere. Yes, sir.
You should be like that. I should be like that.
Try to shove
Nice.
Wait.
Very nice.
He said you're
Roll
gonna get
your
shot.
arms when you're
There you
shooting.
go.
You know, it doesn't work very well like this.
Oh.
It's a little bit easier to keep lofted up there. It's been a few years since I've been using this, so it's kind of lost some of its, awesomeness.
Hey.
Anyway, there's the other thing I haven't quite figured and perfected yet is the fact that there are actual sound effects in here, but I try my best to land on things, and sometimes things work.
This is like a scary pig.
Oh, let's do this one. I think it's this one that does it better. I do it. Or, well, yeah, it's sex. What was this one from?
No, it's from.
No, it wasn't Galaga.
It sounds like the video.
But if I get in the middle, I am the champion. So let's do this.
Mr. Murphy, why'd you record yourself?
I don't sound like that.
Maybe not to your ears.
So now let's do this.
I know.
Now those values are all dimensions of each. You know, it started out the radius of 3, 4, and then it goes out to 6, 7, 9, and 12 for the full thing. Now let's find the geometric probability of landing in one of the orange rings.
That's orange.
Red, orange, whatever.
Let's see how full on orange.
The non-green shaded. So let's figure out, let's make this complicated to start with. Or, if I want to find the probability of landing red, remember we have to figure out then 3 separate regions. Okay? We did something very similar to this before with just 2 of them. We did that before where you had to take your outer ring, this much, subtract everything in, take the next one, subtract everything in, and then take the inside. So what you want to do, 3, 4, 6, 7, 9. That outer one has a radius of 9. You okay with that? So if I have a radius of 9, that'd be a 9 squared pi. I have to then subtract 3, 4, 6, 7 pi. I have to back out the 7 pi, or 7 squared pi. Okay? That gives me the area of that outer ring. So you have 81, subtract 49, what do you get? Yeah. 81 subtract 49 is how much?
32.
68.
That's for that outer ring. I do that again to find the next ring. 3, 4, 6. It's got a radius of 6. Subtract the inner part, which is 4. Well, 6 squared is 36.
So 25.
Excuse me. Yep. 36 pi subtract 16 pi gets me 20 pi. So there's my, so we have a 32 pi here, a 20 pi there, thank you. And then the last one's the easy one. What's the last one for the center?
39.
9 pi. So the total area of those red rings is going to be 32, 20, and 9. We have what, 61, I believe? So the probability of my favorable area, the red stuff, is going to be 61 pi divided by the entire object. Well, again, 3, 4, 6, 7, 9, 12. 12 squared is how much? 144. And like I've said before, whenever you have pies with the fractions, make sure you use the fraction bar, because if you don't, you'll probably accidentally forget to close parentheses and go on from there. So just type in your 61 pi over your 144 pi. Gives me a fraction. Well, me, I did this one. Nope. 0.42. Okay? So there's a 42% chance if I was halfway decent at shooting a bow and arrow, I'd have a 42% chance of landing in red. Now, what's the probability of landing in red is 0.42. What would the probability of landing in the green be?
6-8.
Yeah, no, 58.
Well, 50, yeah.
58. Does everybody remember that? What that means is you're actually using what's called a complement. Not you look nice today. It's the opposite of what's there. Because the probability of an event occurring is 1. Take out the 42, that gives you the other half, not the other half, but the other probability. Okay? That's how probabilities work themselves through. It's fun. You roll your eyes.
Mr. Murphy, you know what the problem with the bow is? It has no pounds behind it on the string.
It's also plastic that costs $1.50. So all right. Probability shaded region. Probability shaded region. So this is the style that we're going to start to look at, where we're going to look at the areas, excuse me, and go through. Which means we have to figure out how are the regions themselves constructed. Well, this one appears as though there was a trapezoid with the rectangle cut out. Or there's another way to look at it. Well, it's not as obviously, guys. It's not a square because your base and height are different. Now, one of the things you can do. The large shape is still a trapezoid. Okay. The shaded region in this case, you can do the trapezoid subtract the rectangle, or you might recognize that if you put these two together, you still get a triangle, don't you? You know what the height of that triangle is, right? 12. Well, if this is 14, that's 14, right? Which means how much is left over for the base of the triangle? 6. There's 3s on each side. So why not just do the area of the triangle divided by the area of the trapezoid? You could do it either way. It's going to work. But sometimes it's a little bit quicker if you see one thing versus another. So triangle, it's easy. 1/2 base times height. So we have a 1/2 of 6 by 12 over area of a trapezoid. 1/2 the height of 12 times the sum of the bases. 14. 20. Half the height times the sum of the bases. What's that? The whole shape, yeah. Remember, it's shaded over the whole thing. Now, what's half of 12? What's 6 times 6? 36. What's 14 and 20? 34. So it's 6 times 34 then, I don't know. It ends in a 4. Throw that in, what do you get? Thanks, Captain Obvious. What is it? 0.17?
18.
There you go. Notice this unit, this last little section here really is a ton of review of all the areas, because you're going to be finding areas multiple ways, whether it's this style or whether it's going to be perimeter apophthegm where you draw your 3 parts. That also shows up.
Whoa, what is that? Sounds like he's spinning.
Probability of landing in the blue. Probability of landing in the shaded region, the blue part here. So this again goes back to the idea of how was the blue created. So I'll give you a second to draw that up. Austin, would you grab the door, please? It's your sector subtract out the triangle. Okay. And then you have your overall, what do you call it? Circle. So this is going to be the area of a sector. Subtract the area of a triangle divided by the area of a circle. Okay? Which means we have to figure out a whole bunch of stuff. Now, it's nice that they show you right off the bat that you have a central angle of 90 degrees. So you know that part for your sector. Excuse me. You also know that these guys happen to be the same because they're both radii. Which means that you have a 45, 45, 90 right away. Now what happens here, if you look at the large triangle, I'm just going to draw it a little differently here. That larger triangle breaks itself into 2 smaller 45, 45, 90s. We okay with that? Where you get opposite one of your 45s happens to be 8, which means opposite the other one has to be 8, and this one is also an 8 there, which makes this side here 8 root 2, which makes this one 8 root 2, which gives you, if I go back to my diagram, that's my radius, 8 root 2, 8 root 2, and this part here is 16. Okay. We see how we did that? Just by using our 45, 45, 90s. Again, tons of review of everything we've done this entire school year. Area of a sector. Area of a sector, central angle over 360 times pi r squared. Fill in the blanks, we have 90 over 360 times 8 root 2 quantity squared with a pi. And I would suggest, well, let's find these pieces separately. So 90 over 360, bless you, is a fourth. 8 root 2, oops. So the area of the sector is 32 pi. Okay. My sector is 32 pi. My triangle had bases and heights of 8 and 16. Okay. It's the 64. And then I go back to my circle, and it's going to be the 8 root 2 quantity squared times pi. I had just done 8 root 2 quantity squared in my calculator, and I have it at 128. So my circle is 128 pi, which means 32 pi subtract 64 all over 128 pi. Notice I'm writing down what I'm going to put in my calculator before I put it in my calculator.
What's wrong with that?
.09. 0.09. It's messy sometimes. There are multiple steps, but you're finding the areas of shaded regions like you have been the past couple of days. Like we did last week a few times, a couple weeks before that. It doesn't go away. Okay? Excuse me. So, let me give you a few of these to work.
Okay.
So there's obviously there's a lot more to geometric probability. There's stuff where we can deal with line segments.
I won't. You won't.
So I went to go.
Whiskey. No. You almost broke it. No.
Wait, I thought we were shooting the boy and arrow. You're supposed to bring this straight up and do it, right? That's how we're supposed to do it.
Ladies and gentlemen, do this on a separate sheet of paper. Do this on a separate sheet of paper, and you have to show your work. Separate sheet of paper, and you need to show your work, guys. Okay? We'll go from there.